Right, welcome back. We're going to talk about polarity's effect on molecular behavior. And this is going to discuss why molecules behave the way that they do in certain situations. First, we need to understand that molecules can range from very nonpolar to very polar and everywhere in between. Some molecules have varying degrees of polarity, and others are very nonpolar or just slightly nonpolar, etc. So this is different than the concept of a polar bond. We talked about polar bonds in a previous lesson where the electronegativity difference of two atoms is in the range of 0.3 through 1.7, and that makes a polar covalent bond, and we can draw a dipole moment where one end of the bond is slightly positive, the other is slightly negative. That comes into play here, but we're talking about the whole molecule instead of just an individual bond. If we happen to have a single bonded molecule, there's just one bond, only one bond going on, then that dipole moment is the important factor. But most cases we have more than one bond going on inside of that molecule. Now, this polarity is part of what determines the behavior or some of the properties of that molecule. So just some basic ideas. We can figure out the polarity of a molecule by looking at its structure, but we can also do it experimentally, and that sometimes is more important to us, and that's what we're going to focus on in our class. We're going to look at the molecular polarity based on experimental evidence. Now, if we happen to have a solid substance, we can do one set of experiments, and that's where we're trying to dissolve the solid in 2 different or 3 different types of liquids. So to understand this concept, we need to know some vocabulary terms. First, we need to know what a solvent is. A solvent is going to be the liquid, and that's doing the dissolving. Then we have a solute, and that's the thing that we're trying to dissolve. That's the substance we're trying to dissolve. It's going to be the solid in this case. And then we can describe what happens as being either soluble or insoluble. Soluble means it dissolves. Insoluble means it doesn't dissolve. And of course, there's various ranges. So you might have 10 grams of a solid and half of it dissolves. So is it soluble or insoluble? Well, it's at least slightly soluble because some of it dissolves. So what you do here is you put this solid in a liquid that you happen to know its polarity. So for example, water. We know that water is a polar substance. So if you put the solid into water and it dissolves, because likes dissolve likes, we know that the solid must be polar. On the other hand, if you put that solid in a nonpolar substance like hexanes, for example, and it dissolves, we know that the substance must be nonpolar. And then you can do vice versa. So if it doesn't dissolve in hexanes, you know that it must be polar because it doesn't dissolve in nonpolar and likes to dissolve its likes. So what we might see for soluble is this solid at the bottom completely dissolves and turns into just a solution. You can't tell where that solid is. That would be soluble. In this case, it's saying that sugar happens to be soluble in water. Now, on the other hand, insoluble would be like a precipitate, or it just doesn't dissolve. That would be like this solid right here never goes away. So that would be if we take a solid and try to dissolve it in a liquid. That's one way to determine the polarity of a substance. Now, we can also do this when we have 2 liquids, but we use some different words to describe what's happening. In this case, we use words that revolve around miscibility, and that's just describing the ability of those 2 liquids to mix together. So if the 2 can mix, they are miscible. Those words kind of sound similar. If the 2 cannot mix, they are immiscible. So for example, you could take food coloring and water and put them together, and those 2 are going to clearly mix. You're going to have a container of water that's now red or whatever color your food coloring happens to be. On the other hand, you could take oil and water, and those 2 won't mix. Those would be immiscible. And like we had with our previous slide, likes dissolve likes, we also have likes mixed with likes. So in this case, we have 2 different layers. This would be immiscible because the polar water does not mix with the nonpolar methylene. On the other hand, over here we have acetone and water, and the 2 can mix. So that's telling us that at least that the 2 must have some various degree of similar polarities. And again, liquids can have that range of polarities from very polar to very nonpolar and everywhere in between. So depending on what 2 liquids you have, likes mixed with likes, you might be partially miscible, but that's harder to tell on these. So it's really easy to tell if they're immiscible. Partially miscible would be harder to tell. So after watching this video, you should be able to understand that we can determine molecular polarity by looking at experimental evidence to see what mixes with what or what dissolves with what. Recall that likes dissolve likes or likes mix with likes, and then also understand that we're talking about the whole molecule instead of just a single bond. Hope that helps.